We all know what a storage is. It's the permanent storage of a computer. Unlike RAM, which is temporary and only holds data while the system is powered on, there are two types of storage devices: HDD, which stands for hard disk drive, and SSD, which stands for solid state drive. Think of your computer storage like a closet at home. When you put your clothes in the closet, they stay there even when you leave the house or go to sleep. In the same way, storage keeps your files, photos, videos, documents, and programs saved even when the computer is turned off. An HDD is like an old closet with heavy doors. It works, but opening and closing it takes time and it can get damaged. An SSD is like a modern sliding closet door. It's fast, quiet, and more reliable. HDDs, as I said, are the older type of storage. You don't usually see them in modern personal computers anymore, but they're still commonly used in data centers. HDDs typically come in 3.5-inch size and contain several internal components. Inside an HDD, there's a spinning disk called platter that stores data, an arm that reads and writes data, and an actuator that moves the arm back and forth. Depending on the capacity of the HDD, it may contain multiple disks and arms. The speed of an HDD is determined by how fast the disk spins, measured in RPM, revolutions per minute. The faster it spins, the quicker data can be accessed. One important thing to consider with HDDs is that they have moving parts, which makes them more prone to physical damage, as I explained with the closet analogy, and they make noise. SSD, on the other hand, have no moving parts. It makes them quieter, more durable, and much faster than HDDs. SSDs also use newer and faster connection technologies, which we will talk about shortly. SSD are smaller than HDD as well. It's 2.5-inch in size. Over time, SSDs became smaller to fit into compact devices. One of the early smaller formats was mSATA or mini SATA, which offered the same performance as a 2.5-inch SSD but in a smaller form factor. Then came M.2 drives, and wow, these are tiny. One of the coolest things about M.2 drive is that they don't use cables. Instead, they directly connect to the motherboard through the PCI Express interface, making them significantly faster than cable-based SSDs. M.2 drives use two main communication protocols: AHCI, which stands for Advanced Host Controller Interface, and NVMe, Non-Volatile Memory Express. AHCI was originally designed for HDDs and later adapted for SSDs. However, SSDs are much faster and needed a protocol that could keep up. That's where NVMe comes in. NVMe was built specifically for high-speed SSDs and allows them to fully utilize the speed of the PCI Express interface. Now let's talk about how HDDs and SSDs connect to the motherboard. HDDs use SATA cables, one cable for data and one for power, as you can see on this picture. SATA was designed to work well with HDDs and uses the AHCI protocol. SSDs initially used the same SATA cables as HDDs. Later, a faster option called SAS cable or serial attached SCSI cable was introduced, increasing the speed from 6 gigabit per second up to 22.5 gigabit per second. There are also other types of storage devices, such as very small portable drives used mainly for storage and file transfer, like the microSD and others. These usually have smaller capacities and are easier to lose due to their sizes. If you can connect to the internet, then your computer has a network interface card, also known as a NIC. A NIC can look like this. It connects to a PCIe slot on the motherboard and usually has one or more RJ45 ports on the outside, allowing you to connect using an Ethernet cable and access the internet. There are two main types of NICs: wired NIC for Ethernet cables and wireless NICs for Wi-Fi. You can usually tell them apart easily. The wireless NIC often has one or more antennas, while the wired NIC has an RJ45 ports or more RJ45 ports. And an RJ45 cable is the Ethernet cable that we talked about in one of our previous videos. You can find NICs for both desktops and laptops. For desktops, you install the card into a PCIe slot. For laptops, you usually connect a network adapter through a USB port to your laptop. If your laptop doesn't have enough ports, you can use a USB hub or port extender that gives you multiple ports. You can also find Wi-Fi NICs in USB forms. They'll look like a flash drive. They're actually wireless network adapters. Next is the cooling system. When you turn on your computer, whether it's a desktop or a laptop, one of the first things you usually hear is the sound of a fan spinning. That fan is part of the cooling system, and its job is to keep the CPU from overheating. As long as your device is on, the fan keeps working to control the temperature. What would happen if we didn't have a fan? The CPU would heat up, and eventually the computer would shut down to protect itself. This is one of the reasons why some computers shut off the moment you open a heavy program. That usually means the fan is faulty, not cooling properly, and may need to be cleaned or replaced. You may have also noticed that sometimes the fan is louder and other times it's quieter. Why? Because it depends on what you're doing. The heavier the task, the hotter the CPU gets, and the faster the fan spins to cool it down. How does it actually cool the CPU down? To cool the CPU, we need few key parts. We need a thermal paste, a heatsink, and a fan. First, we apply thermal paste on the CPU. This fills in the tiny gaps between the CPU and the heatsink, allowing heat to transfer more efficiently. Second, we install the heatsink on top of the CPU. The heatsink is made up of metal, and its job is to absorb and spread out the heat coming from the CPU. Finally, we place a fan on top of the heatsink. It blows air across it, helping the heatsink cool down faster. This process continues until you shut down the computer. Is a fan the only cooling option? Fortunately, no. There's another option that can be quieter and more powerful: liquid cooling. Liquid cooling uses a cold liquid to absorb heat from hot components like the CPU or GPU. As the liquid heats up, it travels through tubes to a radiator where the heat is released into the air. Then the cooled liquid flows back again to repeat the process. It's a constant cycle. This type of cooling is mostly used in desktop computers because it takes up more space and it will cost more. What parts do we need for liquid cooling? A liquid cooling system includes a water block, which sits on the CPU or GPU and transfers heat into the liquid, tubes and fittings, which carry the liquid through the system, a radiator, which cools down the hot liquid using a large surface area, a pump, which keeps the liquid moving through the system, and a cooling solution, which is the actual liquid itself. And yes, you can even use water. There are different types of these parts, each with pros and cons. Before buying anything, make sure to choose what works best for your computer. That was the internal components part 2. Thank you very much.